All right. There we go. So yeah, today we're going to talk about the TypeScript support in Node.js. My name is Marco Ippolito. I do a bunch of Node.js stuff. And we start with a bit of history class today. So when I started working on the TypeScript integration, a lot of people start to ask me, but is it not going to support also other flavors like Flow and CoffeeScript? So I was a bit confused, but I went back in time. And this is the state of JS of 2016. And we can see that there is TypeScript, there is CoffeeScript, there is Elm, ClojureScript, a bunch of things that died in the process. And in 2016, TypeScript was not very popular. It was at the beginning. It was starting to get popularity in 2014 with Angular 2 being released. And so in these years, from 2016 and 2024, things have changed drastically. So this is State of JS 2023. So I wish there was a similar comparison of TypeScript and other JavaScript flavor, but there is not. Because simply TypeScript became the most relevant JavaScript superset. And in this graph, you can see percentage of people who use JavaScript and TypeScript. And I would say that like 90% of developers answering use, for a good part, they use TypeScript. So TypeScript is also the 5th most popular language according to Stack Overflow 2023. And it has almost 12 million downloads per day on NPM. This is per day download. So like saying that TypeScript is not popular and is not something that the ecosystem is using would be a lie. So, yeah. Nice. So what about Node.js? Why Node.js has not implemented TypeScript yet? What's the relationship between TypeScript and Node? So, in the past years, many times it was brought to the attention of the maintainers, the TypeScript support, a lot of issues, a lot of pull requests, a lot of discussion in general about TypeScript support in Node, mostly because other runtimes do it. And like everybody uses TypeScript, so I think it would just make sense to do it. The thing is, there were some challenges to this process. And the first one was it's very hard to get consensus. So Node.js being open governance and with many members, it's not straightforward to get consensus on like such an important thing like TypeScript. There were past attempts to talk about the TypeScript situation. Notably, there was in Bilbao last year. I was there, and there was a proposal on how a potential support for TypeScript could look like, and there was like very good reception. But the proposal did not move to a later stage for difficult reason, and like. As usual, getting consensus is very, very hard in Node. Another reason is that TypeScript does not follow Samware. And Node gives very strong stability guarantees to its users. So a lifetime of a Node.js releases is about 3 years from when it's first created to when it goes to end of life. And in 3 years, I think TypeScript releases like a lot of new versions, and they are not backwards compatible. So that is like supporting TypeScript directly is very hard because it would not follow the same pace of Node. The third problem was tsconfig. So Node doesn't currently have a config file, and adding support for a config file that was not Node would be weird, honestly. So I think that is out of discussion. Also, picking a tool that works out of the box. So there are different tools in the ecosystem, but most of them are in Rust, because the JavaScript ecosystem tooling is moving towards Rust a lot. So with Node being in C++, it was a bit tricky to, first of all, to add Rust to the tool chain is very hard, and having a tool that worked out of the box was also very hard. Another problem was CJS CSM interoperability. So there has been a great work in Node.js from the loaders team to improve in CJS CSM interoperability. There will be talk from Joey and Geoffrey later that will explain this more in depth. But thanks to this work, we could improve the the feeling and the developer experience of Node users, to the point that adding TypeScript felt something doable. The last point is source maps. So whenever you transpile your code, you need to enable source maps to reconstruct the location in the stack trace. And this is something that is not desirable for all the application. Like in production, you probably don't want your source map enabled. So like finding a way to circumvent this problem was also one of the biggest challenges, and no champion, like nobody wanted to do the work. So yeah, because of mostly consensus seeking and all these things related to the technical part that are a bit annoying. So everything started from this conversation that we had in the TSC channel. So it was Geoffrey actually that mentioned the possibility of something called type stripping. So basically, we were talking about on how we could support TypeScript, but without really supporting TypeScript. So we mentioned about SWC, we talked about WASM. So all the like in this chart, you can see all the key points that in the future will become the TypeScript implementation. So what is type stripping? So type stripping was the proposed solution to the TypeScript problem, and it's basically removing types, everything that is in line from the TypeScript, and if the output is JavaScript and can be run as JavaScript, then it works. So we do not ideally do not perform type checking, because type checking is the most unstable part of TypeScript, because it changes with every new version, but the syntax itself is pretty stable. So we don't want to support tsconfig, as we said before, and with type stripping, we just remove everything that is TypeScript, and if the output is valid JavaScript, we run it. So we don't need to support all the different TypeScript flavors. It's just one flavor, and that's it. As I said, we remove inline types. So imagine that you declare interfaces. Interfaces are not in JavaScript, but they do not change at runtime the behavior of JavaScript, so we can just remove them. We have no source maps, because we will see later, but we use the trick to avoid enabling source maps, which was on one of the main problems of TypeScript. And at the end, it's stable across all the TypeScript version, because the syntax, unless a new TypeScript major release, is stable. So it means that we can start supporting TypeScript 5, and we can support it until its end of life. And when a new TypeScript version comes out, like TypeScript 6, we support it in a new Node.js major. So let's go into the detail. So imagine this is some TypeScript code you have. We can just remove this interface, because it's not something that is in JavaScript and it's not affecting the runtime. So we just remove it. And what we do once we have removed that part, we go on to remove other things that are TypeScript. In this case, this is type. We can just remove it. Okay, so this is the output. So the output is valid JavaScript. So we can run this, and it works. So now, how do we preserve the location? So as you can see, we deleted a bunch of stuff from this code, but now like it doesn't match with the original. So the idea came from Ashley, from Bloomberg people, who reached out and told me, like, hey, you basically don't need to delete the code that you remove, but you can just replace it with blank space. So how does that work? So basically, instead of removing, we preserve everything, but we just, all the TypeScript-like syntax, we replace it with blank space, and it works. And like that was very genius. So now we don't need source maps, and it works in the same way. So to support TypeScript in Node, we use a library called SWC WASM TypeScript. So it's basically SWC in the form of a WASM. The reason why we wanted WASM, because we didn't want to add Rust toolchain to Node, which was a bit problematic because Rust does not support in the same way all the weird platforms that Node supports. It is battle tested because it's used by Dino, so thanks to Dino. It supports type stripping, so this technique that we just talked about, it is supported by SWC. So that's great. It is fast. I mean, it's definitely faster than the TypeScript compiler, and it's fast enough for our usage. And at last, we received like amazing support from the maintainers that they, without the maintainers of SWC, this would not have not been possible because they customized the package to Node.js needs and really helped us a lot. So you can see this package has only 200 downloads because it's like only used by Node, basically. Fun fact, like someone already said 2 years ago, just bundle SWC and run the code. So like in all the discussions that took in years, like the solution was already there in a comment, and like it went ignored. But cool, we have it. So so we decided to take SWC and wrap it in another package so that users could basically use the same, have the same experience of the Node.js TypeScript support as an external loader. So imagine that there is a new TypeScript version that comes out, but Node does not support it. So you can use Amaro to do that. And basically as an external loader, so you don't lose the possibility to try newest TypeScript version that are not yet supported. Yeah, Amaro means bitter in Italian, to represent the bitterness of this task. Finally, the 4th of July, I created this pull request about the experimental strip types. It landed in 20 days, which was like crazy fast for Node standards. And I received a lot of support from everyone, so I'm very happy on like the experience. So my motivation for this is I wanted to improve the developer experience of TypeScript users in Node. Honestly, I don't do a lot of TypeScript, but and this helped me a lot because I don't have that TypeScript mentality that a lot of like people who are doing a lot of TypeScript have. So I just see it as a JavaScript user from an external perspective, and I think it really helped to push this forward. So yeah, Node 22.6 features this new experimental flag, which is called experimental strip types. So you can just execute TypeScript files. It has some limitations. So the first limitations is that not all the TypeScript features are supported, so it's a subset of TypeScript. The reason why some of the TypeScript features require transformation, they need to be converted into JavaScript code that they cannot just be stripped. An example are namespaces and enums that do not exist in JavaScript, but they also affect the runtime. So they need to become something else. And in Node 22 4.7.0, we created this new flag called experimental transform types that does this thing. So it allows you to use enums, namespaces, and also enables source map by default, because if you add some JavaScript code, you need to also, you cannot just replace it with a white space, so you need source maps, and it becomes something like this. So if you are like an enum enjoyer, please look at what enum looks like in JavaScript. It's horrible, honestly. So I don't know why you should use it, but anyways. So we decided not to support decorators because decorators are stage 3 proposals, and supporting them would be polyfilling something that would later become part of the language. So hopefully in the next whenever Node updates V8 in the next major, we will have decorators in JavaScript, and so there is no need to polyfill that in TypeScript. We have another big limitation here, that is no JavaScript imports for TypeScript files. So, so right now you cannot, like when you write TypeScript, you need to use the JS extension even though the file is a TypeScript file, because when it will be compiled, it will become a JavaScript file. And it's easier for the compiler to rewrite the extension. Right now, you can enable a flag that is called allow importing TS extensions, but you cannot compile it. It's just for runtime. And this works enough, well enough for Node, but you cannot compile. So it was a big limitation. So with TypeScript 5.7, they released, it's still in beta, but they released a new flag called like path rewriting for relative paths. It's this one, rewrite relative import extensions. So as you notice, we use like very short flags for everything. So yeah, TypeScript will rewrite the .ts extensions into .js. So you can basically, like at runtime, you can use the node strip types, and then you can compile it like you would do normally. So what about existing source code? So a friend of mine has been working on a very cool code mod. So and he's here, so I would like Jacob to talk about it himself.
So indeed, what about existing source code? Actually, sorry. Myself, I'm a Node.js core collaborator. Been working on a lot of the things that Marco was talking about before. And then he picked it up as a champion, currently a technical recruiter at Bluebird. So about existing source code. So now that we have this flag in TypeScript that finally allows you to write your source code honestly and use the real file extensions that it actually has. That is great if your source code does that now, but all of the source code from the past 7 or 8 years probably doesn't do that because it wasn't allowed. So updating this by hand would kind of suck. So the code on the left here is probably what your source code looks like now. So this code mod will fix these things for you automatically. It detects and verifies that like what the files are actually on disk, will intelligently update your specifiers where it is appropriate to do so, and per Node's requirement that you include the type keyword, it will also add that where it detects that you're importing a type. At the moment, there is a bit of a known limitation where when you run this, if your type is coming from a package that has no implementation, it turns out Node does not like that, and it throws a little bit of a tantrum. So if you don't have an exports or a main or an index file, Node is refusing to do it. So I will hopefully have that fixed very soon. And then when you run the code mod, it will be able to do things from like at types. That's it.
So right now, is it possible to, basically, you can just use this code mode to have a node-compatible application, your existing application. And as Jacob mentioned, whenever you import a type, you need to specify that it's a type with the type keyword. The reason why is by stripping everything that is not it does not exist at runtime. If you don't specify the type keyword, the type stripping will not be able to understand that this is something that at runtime does not exist, so it will preserve it, and when you try to import, it will fail. But if you use the type keyword, it will just erase it correctly, and it will work fine. At last, you cannot run TypeScript in node modules. This is very important. So if you try right now to run something in the node modules folder, you will see an error, unsupported node modules type stripping. So the reason why is that we want to discourage authors from publishing TypeScript in their libraries. So the reason why is whenever you import something, your IDE will perform type checking and go into your node module. So if you import a .ts file, it will do the type checking all the way for all the node modules that you use. And if they are nested, and they are a lot, it will freeze your IDE, and it's not something that you want. Also, TypeScript being very unstable in the type checking might not be compatible with your TypeScript flags or with your TypeScript version. So it's generally not a good idea to publish TypeScript files. So we wanted to prevent people from doing it. So the next steps for this is bug fixes. So we have a nasty bug on Windows ARM64. So if you have a surface, please reach out later because we need your help. Probably want to make it faster. I created some benchmarks, but I'm not a performance expert, so if you want to get involved on the performance side, you're more than welcome. We want to add more utilities to Amaro. Amaro is an NPM package that you download from NPM. You can use it as an external loader. So, and it's also used in the node core. So if you, we want to be able to add more utilities so it has a better experience. And I would hope for a flag from TypeScript that prevents user from using enums and all those features that require transformation. That would be amazing. And finally, unflag this feature so that everyone can use it. Maybe not 24, who knows? So yeah, I would like you to give me some feedback. So give it a try. If you want to get involved, you can join the Node.js TypeScript team. There is a repository, and we have bi-weekly meetings. So just check the Node calendar, and that's it.
So do we have questions for Marco? Yeah, you do. Okay.
Oh, there, great. There's also, or as I understand it, there was also a proposal for a while at least, I don't know if that's still going on, to introduce type annotation syntax directly to JavaScript as a sort of at a language level. Do you know how this interacts with that? What's happening there?
So that's still a stage 1 proposal. Mm-hmm. So it's not definitive, and it will probably change. Mm-hmm. But I think this interacts in the way that it makes that TypeScript is not present at runtime, and it's something that gets removed, does not persist at runtime. So in that way, it's similar, but there's nothing to do with that.
Okay, thanks.
Okay. First of all, thank you for trying to introduce the flag into TypeScript to eliminate the features, and hopefully we can make that the default in the future, or at least shame people for not using it. But I digress. Wanted to ask if that problem with missing implementation in a package could possibly be solved if Amaro is already a loader by pretending there is an implementation with the resolve hook.
Yeah, I mean, as an external loader, yes. The problem is that in the core is not used as a loader. So
Okay, that
in the
explains it.
core, that would not work. But
Okay, thank you.
PRs welcome.